Good morning, everybody. My name is Phuc. I am the professor of the University of Information Technology, Vietnam National University, Ho Chi Minh City. Today, I will continue chapter 3 factory. I will help you how to learn relational algebra by example. First of all, I want to give you an overview about relational algebra. Remember, we had the following basic operations of relational algebra. So that selection, the sigma sign, then projection, the pi sign, cross product, set difference, union. We also have additional operation, so that intersection, joint division, and so forth. Remember, since each operation returns a relation, so operation of relational algebra can be composed. Now let me go to select operator. The select operator selects the post that satisfy a predicate. For example, you want to treat the employees whose salary is 30,000, and you can use the select operator like this. The first one is the sigma sign. It means stand for select, and then you use condition. In this case, salary equal 30,000, and then you use employee. Employee is the relation. In the condition in selection may be a simple condition and maybe a combination of simple condition with and or not. Now let me go to an example of select operator. You have a person relation with three attributes or name, age, weight. In this case, you have 5 couples, and in the right of the slide you have a select. You select person whose age is greater than or equal 34, and you have here Harry, Helena, and Peter, a person having age greater than or equal 34. Now let me go to project operator. Project retrieve a column. You see a pi symbol here. And remember, duplication is not permitted. For example, you see you want to take the name of the employee only. So you use a project name from the employee relation. Remember, you see you can compose many operations. For example, here you see you want to take the name of employees earning more than 80,000, and you compose two output together. The first one is the projection, the field name or the attribute name, and the second one is the select with the condition is salary greater than 80,000 from employee relation. Now I go to an example of project operator. In the left, you have an employee relation with 3 attributes called name, age, salary. In the right is project name employee only. It means you take only one attribute from employee. In this case, you take attribute called name. Now let me go to a project operator example. The composition. You have here employee relation with 3 attributes, name, age, salary. And here you have a composition, operator composition. The result of select from employee can be the input of project. In this case, you project only name only, and the result will be a relation with only one attribute. Now let me go to Cartesian product. In mathematics, it is a useful set of all pairs of elements x and y, thus can be constructed from given set x and y, so that x belong to set x and y belong to set y. It defines a relation that is the concatenation of every tuple of relation R with every tuple of relation S. And here is an example of Cartesian product. You have two relations. The first relation is a person relation, and the second relation is a city. When you want to make a Cartesian product, you use the cross symbol. Here you see person cross city. And the result table will have 4 attributes. 3 attributes from person, name, age, weight, and 1 attribute from city relation, city attribute. And here in the concatenation of every tuple of relation person with every tuple of relation city. And remember here, because you have 3 rows, 3 tuples in person relation, and you have two tuples in city relation, so the result will be 6. 3 times 2. 3 times 2 is 6. So the result, person cross city will have 6 tuples. Now let me go to union operator. The union operation is denoted by union as in set theory. It returns the set union of 2 compatible relations. For a union operation, R union S to be legal, will require that relation R and relation S must have the same number of attributes. The domains of the corresponding attributes must be the same. And remember, as in on-set operation, duplicates are eliminated. Now, this is an example of union operator. I have student relation. I have professor relation. And now I make student union professor. And the result here contains 8 tuples. Remember the tuples Susan, Yao, and Ramesha are common in 2 relations, in student relation and in professor relation. So the duplication will be deleted. And we have only 1 tuple in result relation. Now I go to set difference operator. Set difference defines a relation consisting of the tuples that are in relation R but not in relation M. And set difference, S, set difference R define a relation consisting of the tuples that are in relation S but not in relation R. And here is an example of set difference operator. You have a student relation contains Susan, Ramesh, Barbara, Amy, and Chimbe. And you have relation professor relation contain John, Ricardo, Susan, Francis, Ramesh. Now you want to build a relation that is the set difference of professor, set difference student, and you will have John Smith, Ricardo, and Francis. Remember, John Smith, Ricardo, Francis are in professor relation only. They are not in student relation. And vice versa, when you make a table by using student set different professor, you will have Barbara John. Amy, Ford, and Jimmy Watt. Because you see Barbara Jones, Amy, Ford, and Jimmy Watt are in student relation only. They are not in professor relation. Now I go to intersection operator, denoted as intersection. And you see here defines a relation consisting on the set of all tuples that are both in R and S. And you can use the set difference to extract the intersection. You have the formula R intersection S is equal R set difference R set difference S. I'll give you an example about intersection operator. You have a student relation, you have professor relation, and you have the intersection between student and professor. And in this case, the result will contain Susan Yao and Ramesh Shah. Remember, Susan Yao and Ramesh Shah are in the student relation and in professor relation. Now I go to division operator. The division operator takes as input two relations. For the dividend relation, R on schema R, and the divisor relation S on schema S, so that all the attributes in S also appear in R and S is not empty. The output of the division operation is a relation on the scheme R with all the attributes common with S. And this is an example of division operator. You have a completed relation, you have a DB project relation, and you want to divide completed relation divide DB project. In this case, you want to know the student who participate on the DB project. And you see the result will be Fred and Sarah, because Fred and Sarah participate on project. You see Fred database 1 and Fred database 2 in completed relation. And you also see Sarah database 2 and Sarah database 1 in completed. So the result will contain Fred and Sarah. Now I go to natural join operator. Natural join is a dyadic operator that is written as R natural join S, where R and S are relation. And the result of the natural joins is the set of one combination of tuple in R and S that are equal on their common attribute names. And I give you an example of natural join. Remember, you can use natural join to link relation together. For an example, consider the tables, the relation employee and department relation and their natural join. You have employee contain 4 tuples. You have a department contain 3 tuples. And now you want to natural join employee and department. And you see the result relation of the natural join of employee naturals and natural employees natural join with department relation is the set of one combination of tuples in employees and tuples in department that are equal on their common attribute names. And in this case, the common attribute names is the department name. So you see here the department name is finance and sales and production. So you see the first one, Harry, the employee ID is 3415 and Harry worked in finance. So after natural join, you will have the manager will be charged, because in department the manager of department name finance is charged, and so forth. Now I go to semi-join operator. The semi-choice is a joining similar to the natural choice and written as R semi-choice S, where R and S are relation. And you see the result of the semi-choice is only the set of all tuple in R for which there is a tuple in S that is equal on the common attributes. I give you an example here of semi-choice. For example, consider the table, the relation employee and department and their semi-choice. You see the employees and the department, and when you make employee semi-choice department, you will have Sally and Harriet. Sally and Harriet. In this case, Sally and Harriet is only the set of all tuples in employee for which there is a tuple in department, thus is equal on their common attribute names. And in this case is the department name. And you see, in employee, you have Sally and Harriet because Sally and Harriet worked in department sales. And you have department sale in department. So Sally and Harriet will be in the result of semi-choice. Now I go to outer join operator. You have a left outer join and you have a right outer join. Left outer join is written as R equal left outer join S, where R and S are relation. The result of the left outer join is the set of all combinations of tuple in R and S that are equal on their common attribute names. In addition to tuples in R that have no matching tuple in S. Right outer join. The right outer join is written as R right outer join S, where R and S are relation. The result of the right outer join is the set of all combination of tuples in R and S that are equal on their common attribute names, in addition to tuples in S that have no matching tuples in R. I give you an example about left outer join. For example, you see you have an employee relation and department relation. Employee here you have Harry, Sally, Jock, and Harriet. And that relation you have a sale only. And the result of the left outer choice of employee and department is the set of all combination of tuple in employee and department that are equal on their common attributes. And in this case, the common attribute is the department name. In addition to tuple in employees that have no matching tuple in department. This is the reason why you see Harry and George. Harry and George are in employee but have no matching record in department in that relation. Remember the value of manager in this case will be non-value. Now I give you an example about right outer join. And you see the result of the right outer join of employee, right outer join department is the set of all combination of tuple in employee and department that are equal on their common attribute. And you know in this case is a department name. In addition two tuples in department but have no matching tuples in employee. And this is the reason why you see the last tuple in the result. I mean, name will be non-value, employee ID will be none, but department name is production and the manager is charge. Now we go to Phuc outer join, an example. The outer join of Phuc outer join in effect combine the result of the left and right outer join. So you see here is the Phuc outer join. I mean the combine the result of the left outer join and the right outer join. Summary. I want to summarize what I discussed with you in this lecture. First of all, I discussed with you about the relation algebra operators. I give you a lot of examples about select, project, union, intersection, set difference, division, Cartesian product, join, see my choice, left outer join and right outer join and Phuc outer join. And I hope with the example you will understand clearly about the relational algebra operators. Thank you for your learning.